All right, Algebra 1, here we go. We're going to be starting the Chapter 4 notes. And like I had told you before, these first few sections in here are almost identical to what we had done in the solving equations sections, but it's just a little bit different. So before we start the new stuff, let's just review something that we haven't done in a little while. So remember, when we are using our exponent rules, anytime we see a number that does not have an exponent, we want to go ahead and put a 1 there, just so we don't forget to multiply the exponent through. So we're going to multiply this 3 by each of these numbers inside here. So we're going to have 2 raised to the third power times x, and then we'll have 2 times 3 is 6. All right, so there's our first set. Over here, we're going to do the same thing. We're going to say 2 times 1 will give us 3 to the second, and then x 2 times negative 1 will be negative 2. Now I know some of you might be seeing this and thinking, oh yeah, I remember that, we're supposed to move that down. But we're going to save that for the last step, because actually when we combine it with this x over here, it will no longer be negative. So let's see what we get next. So now 2 to the third power is 8. I'm going to bring the other number out front. 3 to the second power is 9. And I'll multiply those in the second step, or in the third step. Next, the x's, when they're being multiplied, remember we add the exponents. So 6 plus a negative 2. So 8 times 9 gives us 72. And then we have x, 6 plus a negative 2 is 4. So there's your final answer. And again, you can see that our exponent was no longer negative, so it didn't need to be moved down. And if you would have moved it down, you could still get the same answer, because you would just subtract 6 minus 2 when you do your division property. But again, it doesn't matter. 2 different ways to get to the same answer. Okay, so new stuff here. Now we're doing linear inequalities. Instead of linear equations, we're going to do inequalities. Okay, so we solve them pretty much the exact same way. The only difference is this, what you see here in the parentheses. When you are multiplying or dividing by a negative number, we have to flip the inequality symbol. Okay, so the inequality symbol must be changed. Here's these symbols. You probably have seen them before. This symbol right here means is less than. This is greater than. This is less than or equal to. And this is greater than or equal to. The other thing I want to point out is that when we're graphing these two kind of fall into the same category, because they will have an open circle. And when these two are graphed, they have a filled in circle. Okay, so make a little note of that. We're going to do it in the problems, but I just wanted to point that out there. So, okay, let's just go ahead and get started on this. And like I said, we're solving these the exact same way. So what that means is I need to move the number that does not have a variable. So that means adding 9. So I will add 9 to both sides. So what do I get here? Negative 9 plus 9 is 0. So my left-hand side is 3x. Now, instead of it being equal to 15, we're going to use this symbol here, which is greater than or equal to 15. And then our last step, just like we did before, to get the x by itself, we'll divide by 3. So x is greater than or equal to 5. Now, the difference between this and an equation, equations we would solve and get x equals 5. So our answer would just be one single number, x equals 5. Now our answer is this whole set of numbers that include every number greater than or equal to 5. So there are tons and tons, like infinitely many, solutions in this problem. Okay, we don't write IMS though. What we do is we graph it. So let's come down here to our number line, and what we're going to do is this number that we got here will go at the middle. The greater than or equal to symbol tells us that it's a filled in circle. Okay, if that was just greater than, without this line underneath, it would be open. We also want to put some numbers to the left and the right of 5, so we'll put a 4 and a 6. And then we want to shade this number line to represent all the numbers that are greater than 5. So again, like I said, there are so many numbers that would fit this solution, like 6, 7, 8, 9, 5 and a half, 6 and 3/4, decimals, fractions, all sorts of things like that. They all fit into this solution. So that's how we represent this, is by shading that number line. Okay, now I don't care how you shade this number line, I just need to be able to obviously see that this is the solution. So I know some people like to put this above the line and they'll do this. I don't care how you do it, like I said, I just need to be able to see which side of the line you have shaded. So I like to do it like this and just shade it. And just kind of like scribble down the number line. So, like I said, it's very similar to what we have already done. The only difference is we have to shade our answer at the end instead of just say, x equals 5. So let's go ahead and solve this next one. So first up, we move the number with no variable. So that means subtracting 5. 5 minus 5 is 0. 21 minus 5 gives us 16. Last step, we will divide by 4, and we get b equals, equals. Look at me. This is a less than symbol. Let's bring down the less than symbol. b is less than 16 divided by 4 is 4. All right, so if all of the solutions are the numbers that are less than 4, we put 4 at the middle, one number on the left, one number on the right. Since this is just a less than symbol and not less than or equal to, it doesn't have the line underneath it like that, that means that we will just put an open circle at that number. So we put an open circle at 4, shade to the left. Make sure you have your arrows on the ends of your shading indicating that it does go on forever in that direction. All right, next. Now, sometimes this will create extra work to do it this way, but I really like to move the variable to the left. I don't know, I'm going to do it both ways and I'll show you why I like to do that. So if we were solving this like an equation, the first thing we would do is move the 7. So we're going to subtract 7 from both sides. 7 minus 7 is 0, they're gone. 5 minus 7 is negative 2. And then over here on the right, we have negative 2m. Now we need to get m by itself, so we're going to divide by this number in front of m. So we divide by negative 2, divide by negative 2. Negative 2 divided by negative 2 is 1. Over here again we have m, but remember, I'm going to put a little star over here. What did we just do? We just divided by a negative number. That means the sign needs to be flipped. So we're going from this, okay, this is how it was facing, to now we're going to flip that and make it face the other direction. So this is our final answer right here. So 1 is greater than m. Now, when we are doing our shading, it's a lot easier to have the variable on the left and the number on the right. But when you do this, again, look at how your arrow is facing. It's pointing at the m. Do you see that? Your arrow is pointing at the m. So it needs to remain pointing at the m. Now let me come back up here and show you the way that I solve them. Now if you could follow what I just did right there, then keep doing it that way. I personally like to move my variable to the left right from the beginning. So what I'm going to do is I'm going to add 2m to both sides. Negative 2m plus 2m is 0. Over here we cannot combine these together because they're not like terms, so we'll say 2m plus 5 is less than 7. Then we subtract 5. 5 minus 5 is 0. So my left-hand side, is 2m less than, 7 minus 5 is 2. So when I divide by 2, I get m is less than 1, which you can see we got the same answer here, right? Both of these are the same thing. Okay? So now how do we graph this? Well, we put the number that we got in the middle. One number to the left, one number to the right. So what you want to ask yourself is this symbol right here representing an open or a closed circle? And hopefully you say open circle. So that's an open circle. All the numbers less than 1 would be over here. And again, put your arrow on the end indicating that it does go on forever in that direction. All right, next example. Now you can see we're adding in here some of these distributive properties, just some of the other things that we did with our solving equations. So multiply the 4 through. 4 times 6 gives you a plus 24. And 4 times negative 2 is a 4 times negative x. Let's try that again. 4 times negative x is a negative 4x. Is less than or equal to 2. Next step, Combine like terms. So I'm going to add these x's together. 3x minus 4x is negative 1x. Bring down the rest. Plus 24 is less than or equal to 2. Move the number with no variable, so I will subtract 24 from both sides. Bring down my negative 1x is less than or equal to negative 22. All right, I'm going to pause here for a second because a lot of people, when they see this, are like, wait, you're supposed to switch the sign. Well, that's only when you multiply or divide, okay? We just subtracted a 24. We don't flip the sign there. The only time we flip the sign here is in this last step when we're dividing by a negative number. Okay, so you can see I'm dividing by a negative 1. So x is now greater than or equal to, and again, put a little arrow or something, make a note so that you remember and realize that we just flipped a sign and, it's changed over to greater than instead of less than or equal to. It's greater than or equal to. All right, put the number we solved for in the middle. One number less than it on the left. One number greater than it on the right. Open or closed circle, what do you think? Hopefully you say closed circle, that is filled in. Remember, anytime you have the line underneath like this, it's a filled in circle. Greater than means I'm shading everything to the right. So there we go. Next. I think this might be our last one. Yep. All right, one more left here. So again, I see that I have a distributive property. So I'm going to start off by multiplying that through. So negative 2 times 4m is a negative 8m. And a negative 2 times 7 is a negative 14. So what I would like you to do right now is I would like you to pause the video and finish this one out. I did the first step for you, so pause the video and finish it and see how you do. I want you to try one on your own. Okay, so hopefully you tried this one on your own and you have an answer. So here we go. Next step, we want to combine our like terms. So that's a 5 minus 14. So 15 is equal to, I like to put my number, equal to. I like to put my number with the variable first. This is supposed to be a less than. So I'm going to put negative 8m, and then this is going to be a minus 9. Okay, 5 minus 14 is negative 9. So now we add the number that does not have a variable, so we will add 9 to both sides. Cancel that out. 15 plus 9 is 24, is less than negative 8m. Next step, we will divide by the number in front of the variable, so divide by negative 8, and we get negative 3. Right-hand side is m. Again, we just divided by a negative, so we need to flip our sign. But this is also the same thing as saying m is less than negative 3. So, either way is acceptable to write your answer. So I'm going to put the number in the middle, one number greater than it on the right, one number less than it on the left. This right here will be an open circle at 3 because it's just less than and not less than or equal to. And less than means we're shading everything to the left. Okay? So there's your final answer for that one. And again, like I said, this is very, very similar to what we had just finished in Unit 3 with our solving equations and stuff. So the only thing that's different is the way that we're ending the problem by graphing it instead of just saying, like this is our answer. We end it by showing the graph. Okay, so if you have any questions, like always, just please let me know and I will get back to you.